Hello everyone, welcome to my YouTube channel Rajesh Chatkuli. Today in this video I am going to solve one problem of power series. Okay, for the problem of power series. Normally we have power series is given by the formula y limit n tends to 0 to infinity. This is Cn x minus x naught power n is equal to C0 plus C1 x minus x0. This is 1, so we are not writing 1, and this is C2 x minus x0 square plus dot 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 up to Cn. Okay, here x0 is normally constant term, which is also known as center of series. Okay, then x is variables, and C0, C1, C2 dot 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 Cn are constant coefficient. Then normally power series for center of series x0 is 0 is given by, in this same formula just put here x0 is 0. That is our formula is infinity n is equal to 0 Cn x minus 0 power n. This is infinity n is equal to 0 Cn x power n. Okay, and this is given by the formula C0 plus C1x plus C2x square plus C2x square plus dot 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 up to n term. Okay, and now let's do a problem for power series. Normally in this one we are having two types of problems encountered in this series. The first one type is given by y double dash plus 2y dash plus y is equal to 0. Here it is in this side there is normally 0, and the second type of problem is normally given by y double dash plus 6y dash plus 7y is equal to 3x. Here it is some certain variables. So I am going to solve both these types of problems, and if you have any doubt, please let me know in comment section. I'll try to respond the doubt. Now let's solve the problem. Okay, here the problem is solved by power series y double dash plus 6xy dash plus 7y is equal to 3x at center of series. 3x at center of series x0 is normally 0. For this one, the power series is given by what is the formula for center of series x0 is 0. Then we have formula y is equal to infinity n is equal to 0 Cn x power n is given by C0 plus C1 x plus C2 x square plus C3 x cube plus dot dot dot. We are using this formula. The equation is y double dash plus 6y dash plus 7y is equal to 3x. Let us suppose this is equation 1. Okay, now let's solve this problem further. So power series is given by y is equal to infinity n is equal to 0 Cn x power n. Then what about y dash? Means that just differentiate this one. What we will get is this one is infinity n is equal to 1 n into Cn x power n minus 1. Then again what will be the y double dash? Y double dash is differentiate this one n into n minus 1 cn x power n minus 2. That is x power n is normally given by n into x power n minus 1. We are using this same concept. Okay, so substitute what we're gonna substitute is y double dash, y dash and y in equation 1. In this equation we are going to substitute this value. The equation becomes y double dash is, oh sorry I missed this one, here it is, infinity n is equal to 2. So infinity n is equal to 2, n into n minus 1 cn x power n minus 2, and then again plus 6 into x infinity n is equal to 1, then n into cn x power n minus 1, then again 7 by 7 infinity n is equal to 0. What we have find cn x power n is equal to 3x. Okay, so infinity n is equal to 2, n minus 1 cn x power n minus 2 plus, here this is x power 1 and here is x power n minus 1. So what we will do is n is equal to 1, n into cn x power n minus 1 into x power 1 plus 7 into infinity n is equal to 0 cn x power n is equal to 3x. Okay, so what we will do is infinity n is equal to 2, n minus 1 cn x power n minus 2 plus 6 into infinity n is equal to 1, n into cn x power n minus 1 plus 1, so 1 gets cancelled, so it is x power n plus 7 into infinity n is equal to 0 cn x power n is equal to 3x. Normally we have to see this limit. Here this is n is equal to 2, here this is n is equal to 1, and here this is n is equal to 1. In this case we have only two options. Either we need to decrease this 2 to 1 and 0 and decrease this 1 to 0, or increase this 1 to 2 and this 0 to 2. So I think it's quite difficult to increase from 0 to 2. That's why let's decrease the series, which we call it shift down. Okay, yes, shift down means if it is infinity n is equal to 2, n minus 1 cn x power n minus 2, then when we are shifting down to 0, infinity n is equal to 0, then add, if we are shifting down, then add this 2 in every n. Okay, here n is n plus 2, n minus 1 is n minus 1 plus 2, cn plus 2, then x n minus 2 plus 2, which becomes infinity n is equal to 0, n plus 1, n plus 2, and then cn plus 2 x n. Now again do for infinity n is equal to how much? N is equal to 1, n into cn x power 1. In this concept what we'll do is, in n, here this was 2 which is shifted to 0, so we add 2 in all the x term, n term, and here this is n is equal to 1 and we are shifting this to 0, so we are adding 1 to all the terms, that is n plus 1 x n plus 1. Now substitute these values. Okay, what we are going to substitute is that after shifting this down we got this value, then after shifting this we got this one. So let's substitute this shifted value in this term. Then what we will get is this n2 becomes how much? So this 2 becomes now infinity n is equal to 0, n plus 1, n plus 2, cn plus 2 into x power n, okay, plus 6, this 1 becomes to 0, then n plus 1, cn plus 1, then x n plus 1 plus thus the last term is as it is, that is infinity n is equal to 0, c1 x power n is equal to 3x. Now what we have to see is that, look, this is from 0 to infinity, 0 to infinity, it's fine. Here it is also 0 to infinity, it's also fine. Here also it is 0 to infinity, this is all fine. And let's see the x power term. Here this is x power n, here is x power n, but here we got x n plus 1. So let's shift down. So let's shift down this one, okay. This one is infinity, n is equal to 0, n plus 1, n plus 2, cn plus 2 into x power n plus 6, infinity n is equal to 0. Let's do this x n, because we are going to shift this down. So this is n, that is n plus 1 minus 1, and again cn plus 1 minus 1, n plus 1 minus 1, okay. You don't need to show this, but I'm just showing this one for your each. Cn x power n is equal to 3x. So this becomes infinity n is equal to 0, n plus 1, n plus 2, cn plus 2, x power n plus 6, infinity n is equal to 0, so n into cn x power n plus 7, 0 to infinity, cn x power n is equal to 3x. Now we came to one situation that here this one summation term is also same, summation term is also same, here summation term is same, and x power n is also same. So let's take these all common, that is infinity n is equal to 0, x power n, then remaining terms are n plus 1, n plus 2, cn plus 2, okay. In this term remaining term is 6 into n into cn, plus here remaining term is 7 into cn is equal to 3x. Generally after this condition we are going to equate power of both the terms. Here this 3x means here 3x power 1, so we can write this one as x power 0 into x power 2 0, x2 0, like this one, okay. So equating both sides power, let's equate the power. Here what we'll get, x power n, n plus 1, n plus 2, cn plus 2 plus 6 into n into cn plus 7 into cn is 3x. I showed this one just to make you clear, you don't need to show this one. So this is for all n is equal to 0, 1, 2, dot dot dot, okay. So put n is equal to 0. Here n0 means x0, 0 plus 1, 0 plus 2, c 0 plus 2 plus 6 into 0 into c0 plus 7 into c0 is equal to 3x. Here is x power 0, so here x power 0, and then if we are going to equate, then this is 1 into 2 c2 plus this becomes 0 plus 7 c0 is equal to x power 0. So 2c2 is equal to minus 7 c0, c2 is equal to minus 7 by 2, C0. We found C2. Okay, so let's find other terms too by substituting n is equal to 1. Put n is equal to 1, then this is x power 1, 1 plus 1. Substitute value in this same equation. Previously we put n is equal to 0, now we put n is equal to 1, again we'll put n is equal to 2, and then we'll substitute in the main equation. Okay, and then 1 plus 2, c1 plus 2 plus 6 into 1 into c1 plus 7 into c1 is equal to 3 into x power 1. So this is 2 into 3 c3 plus 6 into c1 plus 7 c1 is equal to 3 x power 1. So we are only equating this number. Yes, 6c3 plus 13c1 is equal to 3. So c3 is 3 minus 13c1 upon 6, which we got is 3 by 6 minus 13c1 by 6. This one is 1 by 2 minus 13c1 by 6, which is c3. Now again what we will do, we will put n is equal to 2. Just try to find for. So put n is equal to 2. When we are putting this value, what we will get is x square 2 plus 1, 2 plus 2, c2 plus 2 plus 6 into 2 into c2 plus 7 into c2. This one is 3. This one is 3x. We just substitute this n is equal to 2 in that previous equation. Yeah, in this one we just put that value 1, 2 and 3. So this is x square 3 into 4 c4 plus 12 c2 plus 7 c2 is equal to 3x. X square 12 c4 plus 12 plus 7 19 c2 is equal to 3x. In here it is x square, here is no x square term, so 12 c4 plus 19 c2 is equal to 0. 12 c4 is equal to minus 19 c2. c4 is equal to minus 19 upon 12. We have already find c2 value in our equation, that is c2 is equal to how much we have already find is minus 7 by 2 c0. So let's substitute this minus 7 by 2 into c0. Then c4 becomes how much? C4 is given by minus plus, that is 133 c0 by 24. If you want more accurate, then you just go and put n is equal to 3, you will get c5. But I am going to, this is just for sample, so I am going to put only n is equal to 2. If you want, you can just go and put n is equal to 3 and 4. Now substitute the value of c1, c2, c3, c4, c0 in power series formula, in power series equation. That is, what is that power series equation? We have already written that power series equation, that is y is equal to infinity, n is equal to 0, cn x power n. Since center of series is 0, so this is c0 plus c1 into x plus c2 into x square plus c3 into x cube plus c4 into x4 plus dot dot dot. I am writing this only up to c4 because I have found c4. So c0 is how much? c0 plus c1 into x, because we didn't find c0 and c1, and we have derived all the terms in c0 and c1. So how much is c2x? c2 is minus 7 by 2 c0 into x square. Okay, then how much is c3? C3 is 1 by 2 minus 13 by how much we have found? We have already calculated this one value. So let's see. Yeah, C3 is how much? 1 by 2 minus 13, C1 by 6. This one is x cube plus how much we found C4? C4 is, here it is 133 C0 by 24 into x power 4. So let's rearrange these all terms with respect to C0 and C1. C0 plus C1x minus 7 by 2 C0 x square plus 1 by 2 x cube minus 13 by 6 C1 plus 133 C0 by 24. This one is x4. Let's rearrange these all terms. C0 minus 7 by 2 C0 x square plus 133 by 24 C0 x4. Then let's write C1 term plus C1x minus 13 by 6 C1 plus 1 upon 2 x cube. So this one becomes how much? Let's take C0 common. 1 minus 7 by 2 x square plus 133 by 24 x4. Then let's take C1 common. X minus 13 by 6. Oh, here it is x cube, sorry. 13 by 6 x cube. X minus 13 by 6 x cube plus 1 upon 2 x cube. Okay, so the final answer for this one is y is equal to C0 1 minus 7 by 2 x square plus 133 by 24 x4 plus C1 x minus 13 by 6 x cube plus 1 upon 2 x cube. This one is the required answer. Thank you for watching my videos. If you have any confusion, just let me know in the comment section.